Greetings to all. In this video, we are going to see about inferential and descriptive statistics. Statistic analysis in R is performed by using inbuilt functions. These functions take R vector as an input along with the arguments and given the result. Descriptive statistics are very important because if the raw data is presented, it would be very hard to visualize. Descriptive statistics helps to present the data in a more meaningful way, which allows simpler interpretation of the data. For example, if the results of 100 pieces of students' coursework are there, we may interested in the overall performance of those students. We would also be interested in the distribution or spread of the marks. Descriptive statistics allows us to do this. Typically, there are two general types of statistics that are used to describe data: measures of central tendency and measures of variability. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. There are three different measures of central tendency. They are mean, median, and mode. The mean is equal to the sum of all the values in the data set divided by the number of values in the data set. There are three different types of mean, including arithmetic mean, geometric mean, and harmonic mean. Arithmetic mean is calculated by taking the sum of values and dividing with the number of values in a data series. The syntax for calculating mean is mean of x, trim equal to, na.rm equal to, where x is the input vector, trim is used to drop some observation from both ends of the sorted vector, na.rm is used to remove the missing values from the input vector. This slide shows some examples of using mean function. The first command, mean of 1, 2, 3, 4, 5, returns the incorrect result as 1 or calculates mean only for a vector. Since the command is not a vector, hence only the first number is returned. The second command calculates the mean of all the values in the numeric vector correctly. Rather than calculating the mean of the vector created inside the mean function, we can create a vector and then calculate mean on the vector. This is shown in the next command, wherein a vector named sales revenue is created. The mean function applied shows that average monthly sales revenue is 62.5. When trim argument is provided a value, the values in the original vector gets sorted and the number of observations are dropped accordingly for calculating the mean. When trim equal to 0.3, 3 values from each end are dropped from the observations to find mean. Similarly, when trim equal to 0.2, 2 values from each end are dropped from the observations to find mean, and the command which calculates the mean of only 8 values yield the same result, 62.75. A vector named expenses is created for 10 numerical values and 2 missing values. If there are missing values in a vector, the mean function returns NA. To drop the missing values from the calculating, na.rm equal to true is used. Thus, the last command returns the result as 38, which is the mean of 10 numbers existing in expenses vector. The geometric mean is a mean which indicates the central tendency of a vector by using the product of values. The geometric mean is defined as the xth root of the product of x numbers in a numerical vector. The syntax is product of x exponentiation 1 slash length of x, where product of x calculates the multiplication of all the values. Exponentiation denotes the power sign and length of x is equal to the number of elements in x. The first command shows that geometric mean for 3, 4, 5 and 6 is 4.3. The next section checks the result. The value of ANS is 360, which is calculated after multiplying 4 numbers. Since the length of the vector is 4, hence ans should be raised to the power 1 by 4, which means applying square root function twice. Thus, both the results are the same. The harmonic mean is an average calculated by dividing the number of observations by the reciprocal of each number in the vector. Thus, the harmonic mean is the reciprocal of the arithmetic mean of the reciprocals. The syntax of harmonic mean is 1 slash mean of 1 by x, where x is a vector consisting of values. An example for calculating harmonic mean is given in this slide. The median is the middle score for a set of data that has been arranged in order of magnitude. The syntax is median of x, na.rm equal to, where x is the input vector, na.rm is Boolean value and is used to remove the missing value from the input vector. The mode is the most frequent score in the data set. R does not have a standard inbuilt function to calculate mode. This slide gives some examples of calculating median. For determining the median, the values in the vector are first arranged in ascending order and the middle value is taken as a median value. The first function determines the median of a vector of 10 values. Since the vector has even number of observations, there will be two middle terms, value at 5th and 6th position. The median is determined by taking the average value. Hence, the average is 45 plus 56 slash 2, that is equal to 50.5. The next function computes the median for odd number of values 11. Hence, the median will be the value at the middle position. Now, let us see about measures of variability. Variability means scatter or spread. Thus, measures of variability refers to the scatter or spread of scores around their central tendency. The measures of variability indicates how the distributions scatter above and below the central tendency. The different measures of variability include variance, standard deviation, mean deviation, range, interquartile range and quartile deviation. The variance is the measure of how far a set of numbers are spread out from their average value. The syntax for calculating variance is variance of x, where x is the vector or set of values. The mean value for the first data set, which has values 50, 60 and 70 is 60 and the variance is 100. The mean value of the second data set is same as earlier 60 while the variance is 1. This means that the values in the vector are closer to the average value in the second case. Thus, for better determination of the values, it is better to consider variance. The next function determines the variance of the vector units sold. Standard deviation is a measure that is used to quantify the amount of variation or dispersion of a set of data values. Standard deviation is the square root of the variance. The syntax is square root of variance of x or SD of x, where x is the set of values. An example of calculating standard deviation is given in this slide. The mean deviation, that is also called as mean absolute deviation, is the mean of the absolute deviation of a set of data about the data's mean. The syntax is sum of absolute of x minus mean of x divided by length of x, where x is the set of values. An example of mean deviation is given in this slide. A range is used to determine the maximum and minimum value. However, the exact value can be determined by max of x minus min of x. The syntax is range of x, where x is a vector or a data column. The first function shows the structure of cars dataset available in our environment. There are 50 observations for two variables, speed and dist. The second function shows that minimum value and maximum value for speed are 4 and 25 respectively. The exact range is determined by the difference of these values. In this case, the range is 21. An interquartile range is a measure of where the bulk of the values lie. Interquartile range is determined by difference of third and first quartile and is computed in R using IQR function. Quartile deviation is determined by dividing quartile range by 2. Quartile deviation is also known as semi-interquartile range. The syntax for calculating interquartile range is IQR of x and quartile deviation is IQR of x slash 2. Examples for interquartile range and quartile deviation is shown in this slide. Thank you.